So on 51, we are constructing some sort of obtuse triangle, and then we want to construct with our compass and our straight edge an inscribed and a circumscribed circle. So for the inscribed circle, we need the angle bisectors. And the angle bisectors makes our incenter. And then for the circumscribed circle, we're going to construct the perpendicular bisectors, because that's going to give us our circumcenter. So I'll start my triangle over here on another piece of purple, beautiful purple paper here. Okay, so just in the old obtuse triangle, doesn't matter what size is it, as long as it's obtuse. Now, keep in mind that for the circumcenter on an obtuse triangle, it's outside of the triangle, so we want to make sure that we leave ourselves enough room to be able to construct that. So there's my obtuse angle, and I'll connect these sides over here. And then I should have enough room in order to make each of my angle bisectors and my perpendicular bisectors. Okay, so we'll start with making the incenter first. And as we said, that incenter is coming from angle bisectors. Whoop. Okay, now I don't have to construct all of them. All I have to do is construct two of them, because the third one's going to meet at the exact same place, and why do extra work when you don't have to? So I'm going to bisect, first of all, the obtuse angle, and the bisecting of an angle is the sad dead cyclops. So I'll stab my point of my compass into that vertex, make an arc, intersect both sides of it. For obtuse angle, you can't use the same compass setting for your dead guy's eye, so you just stretch this out to something a bit bigger. Now I'm going to start at this first point of intersection on the left-hand side. Make an arc on the top, and then the one over here on the right-hand side. There's our dead guy's eye, and just like before, I'm going to make a tiny little hole where that is. I don't know, it seems like there's something underneath these papers. More papers, that's what it is. Now I'm going to connect that back to the vertex, and I've just bisected one of my angles. Okay. Now, even though I went way outside of the triangle on that one, I didn't have to, because the incenter is always on the inside of your triangle. Now I just need to bisect one more of these angles. It doesn't matter which one I choose. I'm just going to choose this one over here on the right-hand side. So I'll stab my compass into the vertex point, make an arc that intersect both sides of this. Now for an acute triangle, we can use the same exact compass setting. And I'll start here at the top one, make half of the dead guy's eye, and then one on the bottom, the other half of the dead guy's eye. Put a little point where they intersect. That looks good. And now we'll draw in the angle bisector. Okay. And so I could draw in the third angle bisector if I wanted to, but it would intersect at this point here, which is the incenter, which would just be one extra step that I don't have to take. Okay, now the special property of the incenter is that it is equidistant to the sides. And that's what allows us to draw the circle, the inscribed circle that's tangent to each one of the sides. But that equal distance has to be measured perpendicularly. So, for example, if I have myself a point and then I have a side of my triangle, some sort of line that it's not on, in order to make or find the distance to that side, I have to construct a perpendicular segment. and I don't just eyeball where that is. I got to construct it with my compass and my straight edge, and I can pick any one of these sides to do it on. I can't use this segment that's, scroll that up a little bit, can't use this segment that's right here just because it almost looks like it's 90, but it's not. And I'm probably not going to construct it on that side because it's going to be hard to tell the difference. So I'm either going to do it over here on the left-hand side or on the right-hand side. Okay. And in order to do it, it looks like I'm going to have to extend out this side a bit. So I can do my little sad dead cyclops down here. So I'm going to extend out one of these sides of my triangle, my original one. Okay. And now from this point, I'm going to put the point of my compass here, make an arc that's going to intersect both sides of this line here, and then make my dead guy's eye down below. So it doesn't matter what compass setting that I choose, as long as it's bigger than the distance from that point to the line. And just make yourself a big enough arc that's going to intersect this line twice. So here is his sad face, which in this case actually looks like a happy one right now. And now I'll stretch my compass out a little bit more, and I'm going to find the dead guy's eye right down below. So I'll stab my point of my compass in this first left intersection point, make an arc down below, and then from the same, using the same compass setting from the right hand side. So now from, I flip this upside down, we can see the sad dead cyclops there. Alright, so I'll put a point to intersection there where these two arcs meet, and then connect that back to, let me find my straight edge. Here it is. Connect this back to the center, the in-center points. Now I don't need to make the whole entire line, I just need enough of it to hit this line so I can find that perpendicular distance. So I'm going to put up my pencil here, line my ruler, my straight edge up with the intersection of this dead guy's eye. And that's the only part of that segment that I need. If I use, let's say, the corner of a piece of paper or something, I should be able to see that I've just created a perfect right angle right there, which is what we want. That's the perpendicular distance from the in-center to the side, and it has to be the same on all of these sides. So now I'll stretch my compass from the in-center. Let me actually label that with an eye. I'm going to stretch my compass from the in-center to the end point of that perpendicular distance here. Make myself a little mark. Now, usually what I do is I check that just to be sure before I actually draw my circle to make sure that that's going to work. And it looks like that's fine. And notice that it does hit, like whenever I drew my circle, it hit right down at the bottom of that perpendicular segment. There we go. We made a perfect inscribed circle within our triangle. There's the first half of that. And now the second half was that we wanted to make a circumscribed triangle. And the circumscribed triangle, or circumscribed circle, I should say, comes from perpendicular bisectors. So to make the perpendicular bisectors, I just do the two-tailed fish on two of my sides. I pick two of my sides, and wherever they intersect, I have to keep drawing my lines, because for an obtuse triangle, the circumcenter should be out here someplace. It's outside of the longest side of the triangle. So I'll choose to bisect this bottom side, this right-hand side here, and then the left side there. And the reason why I'm going to choose those sides is because this piece that's right here, I don't want to get it confused with one of my perpendicular bisectors. And this thing looks like it's going to get all mucked up. So whenever I find the perpendicular bisector of this segment down here at the bottom, just stretch your compass bigger than half of that segment. And then make your two-tailed fish. Half circle on the left side. Switch your compass around. Same half circle from the other side. Punch some little holes on these points of intersection. And as before, I don't need the whole entire line. I just need to see where that midpoint is. I know, actually, I do need the whole entire line on this one because it's going to intersect out here. So I'm going to make my line and keep going outside of my triangle for this one. Oops. Okay, so it might be up here someplace. So now I'm going to do one more perpendicular bisector over here on the left-hand side and see where it intersects this side. Just so that this is a little bit clearer to see, and it's separate from the angle bisector, so I'm going to make this line red. Kinda. That's reddish black. Okay. Now, I'm going to find the perpendicular bisector of the left-hand side, choose some sort of compass setting. The one I have is perfectly fine, and make my two-tailed fish. Half circle centered at the left-hand point, same exact compass setting from the right-hand point. I'll put 2 points of intersection for both of these. And then connect that with my straight edge and see where it intersects this line someplace up here. Okay, line this thing up. Okay, that's good. Oh wait, I wanted to make those red. Okay, so the point of intersection that we just found right there is the circumcenter. And the special property of the circumcenter is that it is equidistant to the vertices. And since it's the same distance as the vertices, that is going to allow us to draw a circle that's going to touch each of those vertices. The distance from C to any one of those vertices is just the radius of that circle. So I'll put the point of my compass at point C and pick one of these vertices to stretch my compass to. The point of my compass, my pencil of my compass. Before I make my circle, though, just confirm that I should touch each one of these 3 points, and it looks like it's golden. Okay. It is golden in part because one of my students was kind enough to give me a brand new piece of lead for my compass. Look how nice and crisp each one of those circles are. Okay, so we made our circumcircle. I didn't get to complete it just simply because I'm off of my piece of paper, but the rest of this construction is, I'm going to go ahead and say, absolutely perfect.